Okay, hello friends. Today we will be continuing the discussion on cardiac cycle. We have talked in the previous topic, we have given the headings of the cardiac cycle, the phases happening in the cardiac cycle. Now, I want to bring your attention towards these phases, not in so much detail. We need to understand some basic fundamentals. The fundamentals about these events are that we said ventricular systole is having isovolumetric contraction, the rapid ejection, slow ejection. And then we said ventricular diastole is having protodiastole, isovolumetric relaxation, first rapid filling phase, slow filling diastatic phase, and
So let us take them in individually, these headings. Okay, let me tell you first the phases of diastole. Okay, to make life easy. I had diagram last time. I had a diagram also. So let me first write the name of the phase, and or I should do like this. Let me write like this, guys. So if I talk about, I was having systole, I was having diastole. Now systole I will be taking later on. We can take them either way, okay? Because after systole there will be diastole, or after diastole there will be systole. Okay, we can take in either way. Now diastole is having what phases? What phases we had read? We had read proto diastole phase, isovolumetric relaxation, first okay, first rapid filling phase, slow filling, that is called diastasis, and what else? Last rapid filling phase. Last rapid filling phase. Fine. Now I will let you write some points. You don't have to go. I don't know why people start making it difficult. If you follow my words, then it will be very much easy. If you follow my words, remove all your thoughts, whatever you learned. Okay, just give a zero line. Okay, become a zero line, bring a zero line in your brain. Okay, now you can understand better. Now listen to me. Protodiastole means, proto means pro means something which has not now matured. Pro means something which is going to mature, or something which is having something. Not wait, isn't it the word is showing something, or the thing is going towards that. You can think in many ways. So protodiastole means, proto means the period, listen to my words, the period that is before the closure of semilunar valve. Who are the semilunar valve? Who are the semilunar valve? Who are the semilunar valve? Aortic and pulmonic valve. True or false? True, true, true. And protodiastole is the period which is just, the word is just period just before the closure of, just before the closure. Think in your brain that something is closing, but it is just to close. When the blood is moving out from the ventricle. Okay, okay. What is protodiastole? If they ask you protodiastole, now you think in your brain. I will show you the diagram. First, visualize. Is the period just before the closure of aortic and pulmonary. My eyes are closed. Your eyes should be also closed. I should be thinking right now about the two valves, the two sides, right ventricle, left ventricle, and I should be seeing those pipes, isn't it? So I will show you now a diagram. Now I don't have, I think, protodiastolic phase. Now if you see this, this is he is showing, but think, we are thinking about these two valves. We are thinking about these two valves, guys. We are thinking about these two valves, these two valves. These two valves are where? They are right ventricle and left ventricle. And once, that means protodiastole has started, that means systole has ended. That means systole is ending and is moving towards diastole, relaxing phase. And since the systole is proceeding towards diastole, that means these should start becoming closed. But I am telling you, they haven't closed. but they are just closing, just before the closure, the time just before the closure. That's why we said protodiastole phase is for just 0.04 seconds, just before the closure of the semilunar valve, when the blood is moving out through the ventricle. Why this happens? The blood is moving due to the momentum. The ventricle, that it is moving because of the momentum of blood. The blood momentum is doing it. So ventricular muscle is still relaxing. So listen to my words, what I am telling. You used to say in the past lectures, sir, that systole is the place when the blood is moving uh, out of the ventricular chamber. But I am telling you, in the protodiastolic phase, it is the phase when blood is moving out. Sir, blood is moving out. Actually, yeah, it is that small phase when still the blood is moving out of the ventricle due to the momentum of blood. Is it clear? So ventricular muscle, what is the status of the ventricular muscle? What is the status of the ventricular muscle? It starts to relax. In this phase, ventricular muscle is beginning to relax. No, you should not say relax. It has started to relax and still the blood is moving out. So how I remember when as being as a doctor, how I remember I take this protodiastole assay. I take this protodiastole and I write blood out of the ventricle, blood out of the ventricle, uh, just before the closure of semilunar valve. I will give you a tip. I will give you a tip how to remember all phases. The tip is that you have to become a slow person, slow learner, slow time. You have to move with time slowly. You have to dissect the time into nanoseconds, sorry, in seconds, small fractions. Okay, so you have to dissect the time. You have to slowly, you have to stop the thinking in your brain for some time. How to stop? If something is moving, you have to move it slowly. You have to move it slowly. Okay, so that means it is the phase. It is the don't see the markings, don't see anything, just focus on this, just focus on this. I don't have a diagram for protodiastole, but I am telling you, it is the point when they haven't closed, so means it should be like this, means they should be like this, and blood should be going out, but this is going for relaxation now. This is going for relaxation. Are we clear, guys? This is the most important topic I am telling you. It is just relaxing, and at that time also blood is moving out, but the valves are not closed. So what will you now, if I tell you, can you please tell me what is the status of valves in protodiastole? So I teach always my cardiac cycle very differently. This has been always liked by the students. That's why I made a video on this. They like the cardiac cycle the way I teach. I don't know whether I teach in that way, but I always divide them on the basis of status. So I always write status. So in the protodiastole, they say, sir, you should ask us what is the status of the valve right now in the protodiastole. What is the status, open or close? They are no. They are open. So we will say about to close. We will say about to close. About to close, isn't it? So we are understanding it very crystal clearly. And what is the status of the ventricle, contracting or relaxing? You should write in this way. What is the status of ventricle, contracting or relaxing, guys? Beautiful answer. Starting to relax, this is the word. It is beginning to relax. It is started relaxing. So we should say starts relaxing. What a beautiful answer. You people are great. Okay, what is the status of the blood? Ejecting still or stopped? Is it moving out or in? Blood still moving out, still moving. Are we clear with protodiastolic phase? Beautiful. Now what was the second phase? You will tell me what comes after protodiastole. We are talking about diastole. So now there should be an isovolumetric relaxation. What a beautiful answer. IVR, isovolumetric relaxation. Isovolumetric relaxation. Now listen first, then we write. There is a way we should first understand, then write. Okay, isovolumetric relaxation. I should not write volumetric. I should write isovolemic. Isovolemic. Okay, let me write it small. Isovolemic relaxation. Isovolemic relaxation means now you will tell me if here it was about to close, what will be happening here? Will it close or open? We are going directly, guys. Close, 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 close. Very nice answer. So we should write. First, I should speak, okay? Then we write. Okay. First, I should make you understand. I should say a statement, then we write. Okay. It is the it is the time, it is the time of diastole in which the closure of semilunar valves is happening and ventricle is relaxing as a closed cavity because every valve will be closed and there will be some amount of blood, that is called end systolic volume, that is called end systolic volume. I will make you understand. First listen. And what will happen to ventricular pressure if you are relaxing as a closed cavity, nothing doing, nothing happening? What is there? Zero. Ventricular pressure becoming zero. Okay, 0 mmHgs. So at the end of isovolemic relaxation, you will be having the lowest ventricular pressure. At the end of isovolemic relaxation, you will be having the lowest ventricular pressure, that is 0 mmHg. 0 mmHg. Okay, so uh, yeah. Now I want to tell you like this: aortic valve is what will happen now. What is the status of aortic and pulmonic valve? What is the status? So valve. What about the valve? Valve is closed. But if you are my student, will you tell me which valve will be closing first? Which valve will be closing first? That's a beautiful answer. That's a genius answer. Aortic valve will close first, followed by the closure of pulmonic valve. This is the concept we have. So aortic valve will close first. So we will write because we know. Because we know. So aortic valve will close first, followed by pulmonic valve. And I hope we know the reasons, isn't it? Yeah. So that reason we know, we don't have to speak that. We know that. Aortic valve closes first, followed by the pulmonic valve. Followed by the pulmonic valve. And will you tell me which sound will you produce if they are closing? Yeah. Which sound will be producing? That's a beautiful concept. We're integrating everything. S2 sound. Yeah, exactly. So we will be listening to S2 sound. So S2 sound will be listened in which relaxation? Isovolumetric ventricular relaxation. Isovolumetric or isovolemic ventricular relaxation. Who will cause splitting of this sound? Who will cause splitting of this sound? We are integrating everything. Inspiration or expiration? Inspiration. That's a beautiful. So you should write here. Inspiration will cause splitting. Inspiration will cause splitting. Inspiration will cause splitting. Are we clear, guys, what we are writing? You should enjoy writing the note. Why? Because you are understanding. If you are not enjoying the note, that means you are not able to understand. If you are enjoying to note, if you are enjoying to write the note, that means you are understanding. Okay, that is the beauty of writing a note, that you are understanding, then only you can write. It's not that we have to write only. Okay. Now, what is the status of the AV valves? If I am saying it is isovolemic, should the things come inside or move outside, or everything should be closed? Everything should be closed. In the isovolumetric contraction, every relaxation, everything should be closed. No changes should happen. You are saying, sir, isovolemic. That means ventricle should relax, but should not be getting added with the blood or subtracted from the blood. Should not have any subtractions or additions of blood. That's why I have to keep all the valves closed. That's why I will say AV valves are also closed. So AV valve is What is AV valve? Tricuspid and mitral, that is atrioventricular valve. These all will be closed. Mostly will be closed. Huh? I will say mostly will be closed. Okay. Now most of this phase you will be having the closure. Okay. What is happening to ventricular pressure? What is happening to ventricular pressure? Ventricular pressure is decreasing rapidly because the ventricle is relaxing. So we will say ventricle is relaxing. Here it was starting relaxing. I will say relaxing. Here relaxing plus decreasing the pressure. Plus pressure is decreasing. Pressure is decreasing. Fine. Because your ventricle is relaxed. That's why your pressure is decreasing. When you relax the ventricle, pressure will decrease, because if you open this chamber, what will happen? Pressure will decrease. If you are opening this chamber in the ICU, yeah, we have the image here. Why we are not using the image? So if I see this is isovolumetric relaxation, can we see atria is relaxed? Can we see now? I don't have to take atria right now. I'm talking about ventricular system, so it will apply to atria also. So ventricles are relaxing, guys. Can we see the chamber is increasing? Ventricle is relaxed. Ventricle is relaxed. And can we see valve is also closed? Can we see aortic and pulmonic valve is closed? Can we see tricuspid and mitral valve is closed? Is there any doubt? Isovolumetric ventricular relaxation. Isovolumetric ventricular relaxation. Okay. Now what is happening? So what is happening to the volume of ventricle? What is happening to this was about pressure. So what about, I should write here, what about the ventricular volume under this heading? Okay, so what about the ventricular volume? Exactly, it is constant. Now you can use the word constant because it's isovolumetric, because all valves, if they ask you why is it constant, you should say that all the valves are closed, all the valves, all the four valves of the heart are closed. Okay, I will be telling you in the JVP there is a notch seen. Please, you should write it here. You should write a notch name. I will be teaching in JVP. There is a blip. There is a blip seen. Blip. Okay, there is a blip seen. Blip. Blip seen once the aortic valve is closing. Once the aortic valve is closing. Due to that closure, you see a notch on the graph. I will be teaching you that. That notch is called as dicrotic notch or incisura. Okay, you should remember this. I'll be teaching you in JVP. Okay, so you will be seeing a notch. That notch is called dicrotic notch. Dicrotic notch or incisura. 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 What is incisura? If they ask you, you should say there is a blip in the aortic pressure. When we are using a graphical method to measure the aortic pressures, to represent the pressures, what we see, there is a blip, sudden blip, a notch is seen because of the closure of the aortic valve. This is called dicrotic notch or incisura. Okay. Now you tell me, guys, if you are decreasing the ventricular pressure more than the atrial pressure, will the mitral valve open or not? You are decreasing the pressure. Will the mitral valve open or not? Yes, it should open. So it is, sir, all the game is about the pressures. Why not? Okay. So we will be reaching which phase? Rapid ventricular, first rapid filling phase. First rapid filling phase. So we will be reaching in which phase? Are we moving with the phases or not? We are not confused. I hope we are not confused. We are moving in sequence. We are moving slowly. Even if it takes us months to study, but we will understand it because it's important. So third I am going into first rapid filling. Now I want to tell you first what is end systolic volume and end diastolic volume. These are two words which you get confused. It's not related to this, but yeah, I had to speak this ESV in the isovolemic relaxation. I will tell you ESV. Let me make you right. ESV is end systolic volume, and systolic volume. EDV is end diastolic volume. And systolic volume means the volume of blood which is remaining in the ventricle at the end of systole. The volume of blood which is remaining in the ventricle at the end of systole. At the end of systole. So you have finished the systole. Now whatever amount of blood is present in the ventricle will be called end systolic volume. Now what is end diastolic volume? End diastolic volume means the volume of blood which is present in the ventricle once you are finishing the ventricular diastole. So the volume of blood which remains at the end of diastole is called end diastolic volume. End systolic volume means the amount of blood which is present at the end of systole in that ventricular systole. Okay, we are taking ventricle as a reference. The volume of blood which is remaining at the end of diastole is called end diastolic volume. The pressure which is generated at the end of systole will be called end diastolic pressure because of this volume. The pressure which is remaining at the end of diastole will be called end diastolic pressure. Isn't it? We can write ED, ESP, EDP, ESP, EDP. Are we clear with these two terminologies? Okay, now this is done. So now you will tell me what is happening in the isovolemic relaxation. So now we talk about the first rapid filling phase. Now in first rapid filling phase, we have written it in full. So I should use the acronym here. First rapid filling phase. First rapid filling phase. What we said, sir? Sir, what? First rapid filling. That means you have to fill. Sir, you are talking about ventricular diastole. Yes, that means filling. Yes, sir. That means what? That means I have to open the AV valve, open the gates. Open the gates. Where are the gates? Sir, you have to fill the ventricle. Yes, sir. Rush the blood. Rush the blood. Can we see the blood rushing? Can we see the blood rushing, guys, in this diagram? Guys, my dears. Can we see the blood going towards the ventricle? Can we see it is the rapid filling, rushing? Can we see how beautifully he has drawn the diagram? The rushing is happening. The rushing is happening. So you will be allowing the rapid entry of blood into the ventricle. You will be allowing the rapid entry of blood into the ventricle. Now you will be telling me, is there a now development of a gradient, a pressure gradient between the atria and the ventricle? Is there are very high changes of pressure happening? Pressure changes will be happening across these two chambers. So in the first rapid filling phase, there is opening of atrioventricular valves, which is the purpose is the opening purpose is the purpose of the opening is to allow the rapid entry of blood to fill the ventricles rapidly. We want the ventricles to get filled rapidly, and the pressure gradient will be changing at a higher level between the atria and the ventricle. I am not if I take atrium, then I should say one atrium. If I say ventricles, I should say many ventricles. So if I say atria, that means I'm talking about two atria, two atrium, isn't it? Which becomes the plural. So if I say ventricle, that means one ventricle. If I have to say both ventricles, I will say ventricles. Are we clear with this terminology? Whatever I'm using. Okay. Now I will tell you in the rapid filling phase what is opening, which valves are opening. So you will say in the mitral in the sorry, I should write first. So what is the status of the valve? Mitral open. Okay, first I should say AV open. So AV has mitral, AV has tricuspid open. Mitral open, tricuspid open. Okay. So what is happening? Filling from atria to ventricle, filling from atria to ventricle, filling from atria to ventricle. Okay. What is happening to aortic pressure? What is the status of aorta? What is the status of aorta right now? Can you tell me right now the status of aorta? Aorta, not atrium. Aorta status. What is the status of aorta? In the rapid filling, sir, aorta is decreasing. Sir, the pressure is aorta is decreasing because it is still sending that small blood into the small arteries, isn't it? So aortic pressure is decreasing. Aortic pressure continuously decreases, guys, continuously decreasing. Are we clear? So if they ask you a conceptual question, what is aorta doing? Sir, nothing. Aorta is still distributing the blood there at the small levels, smaller arteries. So what is happening is rapid flow of the blood is happening from the atria into the ventricles, producing dash sound, dash sound. It's a no S3. It produces S3. It produces S3 because rapid filling phase is S3. Okay, so we learn because of integration. So we have S3 sound. What? S3 sound. So S3 gallop sound. So we have S3 sound production. We have S3 sound production. That's why I said a physician has an eye, a clinician has an eye, a doctor has an eye, and it is pathological. It is normal in children, but it is pathological in adults. Okay. Now, guys, I move to the last slow filling. I should go to diastasis phase. Okay. So I should say diastasis phase. So diastasis phase. Diastasis phase. The phase of diastasis. What is diastasis? Basically, this phase is the longest phase of cardiac cycle. Longest phase of cardiac cycle. Longest phase of cardiac cycle. Okay. So what is happening in diastasis? In diastasis, now you tell me, you uh, you have taken you have taken a water bottle, okay, and I tell you, I give you another big bowl. Okay, I give you a big bowl. Let me make it like this. So I give you a big bowl, I give you two things, and this is the water bottle. This is the water bottle. This was up to this mark. Okay, this is empty. Now I tell you to fill it. You will be having a rapid filling from this. Okay, it is having more blood, so you will be having rapid filling. But after you have filled it, you will be slowly now having a flow. Now, firstly, if I shake this bottle, if I shake this bottle like this, if I shake this bottle like this in my hand, this is a small bottle, by the way, medicine bottle. So if I shake it and now I suddenly invert it, what will happen? All the pressure, all the fluid will come fast. It will rush. It will rush. But since the volume is decreasing, you will be having a slow passage of now. Are we clear? So there will be now a decreased filling, a slow filling will be there. That's why we call it a slow filling phase. Are we clear? So what if they ask you what is diastasis? It is the longest phase of cardiac cycle, and ventricular filling is happening, but at a slower rate. So continuous ventricular filling is happening. You think it feels that nothing is happening, but yeah, there is a phase that slowly something is getting filled. The things from above is getting empty into down. Okay, let me show you this image. Has it shown this? So this is the rushing of the blood, but once you have filled it, now there will be the last columns of blood which will be emptying, but slowly, because you have filled the ventricles in the rapid filling phase itself. Okay, so you are doing a diastasis phase where you have a reduced ventricular filling. Are we clear? So in the diastatic phase, you will be having a ventricular filling is still happening, but at a slower pace. Okay. Now you tell me, will the heart rate determine diastasis or not? Again, that concept. Will my heart rate determine? Exactly. My heart rate will determine whether the diastasis will happen or not, whether the ventricular filling will happen or not. If I have an increased heart rate, I will decrease the time. That means I will decrease the time of ventricular refilling. That means I will be decreasing the ventricular refilling time. Is it clear? Is the diastasis phase clear, guys? Is the diastasis phase clear? Okay. Now I take your focus towards next last phase, which is, in many books they may be writing it differently, but yeah, I am describing every part. Okay. Now there is a concept I will be telling you that, and first I want to tell you last rapid filling. What does it mean? Okay, then it will make there will be it will make meaning for you. It will make meaning for you. Okay. I want to say this last rapid filling phase. Last rapid filling phase means this is the phase where atria will now contract, because you have emptied everything and now atria will contract. Okay. Now you tell me, what was happening in the diastatic phase? Was it a slow filling or a fast filling or a rapid filling? Was diastatic phase a slow filling or a rapid filling? It was a slow filling. But if you increase the pressure with atria now in the last rapid filling phase, will the filling happen rapidly or not? Will the filling happen rapidly? Exactly. So last rapid filling phase, if done by the atrial contraction, will cause a rapid filling. It will again do it jump to rapid. Okay. What is the duration of this? It is equal to atrial systole. It is equal to the atrial systole. That's why it is equal to atrial systole. That is 0.1 second. Can we now understand why it is equal to atrial systole? Can we now understand? Okay. That's why I yesterday told you to write that table. It would make meaning on the next day because I had that yeah, it will help you in that. Okay. Now we have two words again used for this. What I told you, the first rapid filling phase, the last rapid filling phase. No, there are two words which are used in the books. You can say active filling of ventricle, passive filling of ventricle. Active filling of ventricle, passive filling of ventricle. Okay. So I want to make it clear for you today. Okay. So what is happening in the last rapid filling phase? Yeah, we did not write. We should say in this case there will be what there will be rapid. That means mitral and this is still open. That means mitral and this is still open. That means the tricuspid and mitral, they are all still open, isn't it? Because they are allowing the blood to come. So rapid filling because of, you have to write this, because of atrial contraction, because of atrial contraction, and its duration is equal to atrial systole. Its duration is equal to atrial systole is equal to 0.1 second. So you should write like this. This is the way how we remember things. Okay, guys, fine. So that means, can I say with this we reach to a stage, that is we make the volume of the ventricle as end diastolic volume. Can I say with this, with the full ventricular filling, I have reached to a point of end diastolic volume, because we are ending the diastolic phase and we said end diastolic volume is that volume which is present at the end of, here concerned about ventricles, so ventricular diastole. Ventricular diastole. Is there any doubt? Now I want to make those two statements. First, active filling, make a box, small box in your note. One, make active filling. What is active filling? Active filling of ventricle means when the filling of the ventricle, you are actively doing something like you were doing in the active transport, that you were using an ATP. That means you are working. That means you had to work to bring something to a conclusion. So if I say active filling of a ventricle, it means if the filling is happening because of the atrial contraction. If I say, see, listen to my word. If I say active filling of ventricle, active filling of ventricle means this is ventricle, this is atria. Active filling means when the atria has contracted, when the atria has contracted to fill the ventricle, to fill the ventricle. Or you also call it, that's why you call it LRPF, isn't it? Can I call it LRFP? Last rapid filling phase, because it is happening because of the atrial contraction. So we say is also as LRPF. Now they will ask you a question, a very nice genius question. They will ask you how much blood is it contributing? If you contract the atria against the relaxed ventricle, how much blood you are contributing to the ventricular side? You will say it is contributing approximately 30% of the total ventricle filling. So whatever you have in the ventricle, it's 30% has been given by the atrium. It's 30% has been given by the atrium. Is it clear? What about passive filling? What about passive filling? What is passive filling of ventricle? Passive filling of ventricle means when filling is happening without the contraction of atria. When the filling is happening without the contraction of atria. Contraction of atria. Here it is happening with contraction of atria. With contraction of atria. So that means it will include FRFP plus diastasis. That means it will include FP plus diastasis, because in diastasis also you are not contracting anything. It's just that column of blood moving downwards slowly. No, you can think like a gravity thing in the brain, that something is coming down with first gush of blood like a waterfall, and once you are finishing the waterfall, what will happen? The gravity will actually tend it to bring it downwards. So FNFP, FRFP plus diastasis. It contributes naturally. If from the 130 is being contributed by active filling, then 70% should be contributed by passive filling. 70% should be contributed by passive filling, isn't it? So 70% will be contributed by passive filling. And that's why we say it is a passive filling phase. You are not doing anything. It's just happening as a normal cardiac cycle. Now you tell me, guys, if I increase the heart rate, will I decrease the passive filling of ventricle or not? Will I decrease the passive filling? So will my atria come into existence? Will the atria take the charge? Will the atria contribute more blood? So that means atria has to contract. That means atria at that time, if you were saying 30% it was being in the normal cardiac cycle, in the heart rate is increasing. That means you are not giving the ventricle to relax. That means you are not allowing the ventricle to fill. That means you are not actually you are actually decreasing the ventricular diastole. That means atria should come into power so that they can give the blood, so that you can get more ventricular filling. That means atria will increase its capacity to 40%. So in case of increase in the heart rate, you will be having atrial contraction, which will contribute about 40% of the that ventricular filling. So you should remember, in case of increased heart rate, it will be approximately 40% contribution to the atria, from the atria actually, from the atria. Is there any doubt, guys? Is there any doubt in the? So can we have a understanding? Can we have a conceptual review? Because till the time you don't understand, I'm not going to end the lecture. Okay, now listen to me. Now listen to me. You have to speak with me only one line. Okay, you have to say yes or no. Okay, just don't ask any question in the middle. You can ask in the end. Okay, now I say diastolic phase. Ready, get, set, go. Diastolic phase has started. That means protodiastole. What is happening in the protodiastole? The valves haven't closed yet. The valves haven't closed yet. They are just about to close. But blood is still moving in the aortic and pulmonic valve. Blood is still ejecting out of the ventricle, because recently systole has finished. So I am going into diastole. So some amount of blood should be going due to the momentum of the blood going through the out from the ventricular muscle, isn't it? And the ventricular chamber is relaxing. Ventricular muscle is relaxing. That's why you are having a protodiastole. Now, what is the status? Semilunar valves are still closed. They are still closed. They are about to close. I can say, okay, just before the close. They're about to close. Okay, this is the way we wrote, isn't it? Now I go into isovolumetric relaxation. That means in this point of time, ventricular pressure should become the lowest, approximately 0 mmHg. At the end of this isovolumetric relaxation, what you should have is there should be definitely a closure of semilunar valves. And now if I ask you a tricky question, when will the isovolumetric relaxation finish? Will it end with AV valve opening or not? Isovolumetric relaxation, will it end with AV valve, atrioventricular valve? Because atrioventricular valve, left and right side valves, once they open, they will bring the blood. You are not doing isovolemic because volume is changing. You are filling the ventricle. So in the isovolumetric relaxation, you will be having semilunar valves closed, opening, and it will end with the AV valve closure, AV valve opening. Ventricle is relaxing as a closed cavity, because you have relaxed, because you have closed every valve, you have relaxed every valve, you have closed every valve. So you will be having only a little amount of end systolic volume left. Now you are going into the first rapid filling phase, where you are just opening the atrioventricular valve, because sir, in diastole filling is happening. That's why I'm talking about first rapid filling phase. This allows the blood to rapidly enter the ventricle, to rapidly fill the ventricle, so that Due to this course, due to this, what happens is the pressure gradient develops between the atria and the ventricle, and that too a very high pressure gradient. And that to a very high pressure gradient. This rushing and gushing of blood into the ventricle will produce a new sound that is called an S3 sound because of the rapid flow of the blood from the atria into the ventricle, which is to be taken as normal in general, but yeah, in adults it is taken as a disease that we will be learning. And what is happening to the aortic pressure? The aortic pressure is decreasing in its pace, is decreasing. Constant decrease is seen because the blood is continuously filling the small arteries. The blood is rushing to the small arteries. That's why it is. Then I move to the phase of diastasis, which is the longest phase of cardiac cycle, where you see a continuous ventricular filling is happening, but not like the first rapid ventricular filling phase, but at a slower rate. But still is a passive process. And the time which is needed for the diastasis, if you increase the heart rate, you will be decreasing the diastatic time. That is, you will be decreasing the ventricular filling time. That means you are not making the time available for ventricular refilling. You are not making the time available for ventricular refilling. Are we clear? So diastatic phase is the, so what will you listen? What will you see? Will you be having the least ventricular wall motions? Do you know this word? We use this in echo. So will you be having a least ventricular wall motion because you are slowly filling it? See, if I fill something, some motions should happen. When you fill a bucket or something, some motions happen outside. Yeah, some motions happen. So if you are filling it slowly, no motion will happen. So that means the ventricular motions will be least in which phase? Dash phase. Which phase will be having the least? Which phase? Very nice answer. Diastasis is having the least ventricular. So diastasis phase, where is the diastasis? Yeah. So in this diastasis phase, you will be having, please make a star, ventricular motions will be less. Ventricular motions are less. What is the status of the valve? Still open. Aortic pulmonics are closed because you are filling. I'm going to the last rapid filling phase. Last rapid filling phase is the phase of the ventricle when the active filling of the ventricle will happen. The contribution of further 30% which is left will be done by the atria because of the atrial contraction. Now again the filling will turn towards rapid. First you were having rapid, slow, rapid. The phase was such that rapid, slow, rapid. In first rapid filling phase you were having a rapid filling. In slow filling or diastatic phase you were having a slow filling. That's why ventricular wall motions were very much least. The last phase of last rapid filling phase of this diastole, the last phase of this diastole, I can say, last rapid filling phase is same as atrial systole, duration 0.1 seconds. And you are having a rapid filling. This is the important point you have to remember. But remember, this diastatic phase, what we talked, this diastatic phase will increase to, this last rapid filling phase will increase to 40% in case of increased heart rate. That's why the sound become, I'll be telling you that. Okay. Are we clear, guys, about this concept? Is there any doubt in understanding? Was it tough? Was it difficult? It was all logical. It was all logical. God made everything logical and made you also directed you to understand with logic. Okay. It's not something which is hidden. You can use your common sense. Okay. Because if you fill something, you want to remain, you have to make the continuity of the boundaries. You don't want a hole in your bucket if you want to fill the bucket. You don't want a hole in a bucket. You want to fill the bucket, very continuity should be maintained. That's why the valve should be closed. Clear? Now I go towards the systolic phases. Okay. Now, so phases of systole. What are the phases of systole we learned? We said isovolumetric contraction, rapid ejection, slow ejection. Okay. Now, in the isovolumetric contraction, now you will tell me, will this contraction happen? You are now going to systole. Sir, systole. So I have to talk about contractions. Yes, sir. So in isovolumetric, let me write, in isovolumetric contraction, what is happening? the ventricular pressure will start to rise, isn't it? But you are having isovolumetric. That means, sir, still the volume is not going out. Should the AV valves be closed or not? Should the AV valves be closed or not? So I should write the valve status. The valve status will be AV valve closed, because isovolumetric contraction. I have to do isovolumetric contraction. I have to do isovolumetric contraction. So I will be increasing the pressure more than the atrial pressure, but the AV valves will be closed. The ventricular pressure is increasing much greater than the atrial pressure, because I have to contract, but I am building a pressure. You know, when the jet has to fly, what it does? It actually makes the engine hot. First, you prepare the engine. When you fly, what happens? The aeroplane is sitting on the runway, not doing anything, but just increasing the volume which you are listening to, because it has to fly very much high. That is what is applied to your life also. When you have to start something, what we do, we don't directly jump. We first fuel, we start fueling the aeroplane. Then we start generating, the energy which I need to fly. I need to have that escape velocity, I can say, so that I can fly off the ground. It can't happen that I will directly take that to the sky. I have to generate so much force so that I can smoothly and swiftly fly in the air. Okay, guys, are we able to understand? So same way, the ventricle is trying, he is trying, he has to eject blood. So what he is doing, he is trying to maintain that pressure so that he can give you a very nice height. He can give a beautiful ejection. He can give a nice ejection fraction. The pressure, making pressure is important, because he has to supply the blood to the systemic vasculature. So he should have such a beautiful mechanism of pumping so that it can make a pressure so much that I suddenly open the gate and blood will rush out. And blood will rush out. I suddenly make so much pressure in a bottle. You have you taken the Coca-Cola? I hope you take the Coke. So what happens is, what you do is, the carbon dioxide which you are shaking, what you are doing actually, you are increasing the pressure. You are increasing the pressure inside, but once you open it, what will happen? So think like that. So you are making such a pressure that closed Coke bottle is isovolumetric contraction. That isovolumetric ventricular contraction, you can understand, is Coke bottle. It's not yet rushed out, but once I open the valve is the lid, the valve, I will be able to see a very nice ejection, rapid ejection will happen. So I give you an example. This is the best example I give to my students also. This is your Coke bottle. Now you have to go into ventricular systole. You now the heart is not doing something, that it is shaking. But I'm giving an example that you have to make a pressure. Heart makes a pressure by compressing like this. Heart makes the pressure by increasing the pressure slowly, 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 slowly. Take that small time. You will say, sir, why, how this is happening? It will take more time. No, we are getting ready. Exactly. We are getting ready to eject blood. We are making a pressure gradient. Very nice answer. We are making a pressure gradient so that we can eject the blood. Are we clear? So what we do is, so what we do is, we are increasing the pressure. We are increasing the pressure. So we are closing it. We have closed the valve. The valves are closed. The valves are closed. But I'm increasing the pressure in the isovolumetric contraction. AV valves are still closed. My AV valve is still closed. But I have to bring it, throw it from this side, isn't it? Aorta and pulmonic, isn't it? Two sides of the chamber. Now, once you are increasing the ventricular contraction, will your AV valve close? Because just now you came from the ventricular filling. That means you are now closing the valve. You just now came from the ventricular filling, isn't it? Last rapid filling phase. You were the last rapid filling phase, isn't it? You told me, sir, last rapid filling phase, I was filling the ventricles still because of that atrial contraction. But now I am telling you, I am getting ready to fly. I'm getting ready to fly. What I will do, I should close the AV valves or not, so that I can start it. So AV valves will close. Which sound produced, guys? Sound produced is S1. That's a beautiful concept. S1 sound will produce because of the increased in ventricular pressure. So ventricular pressure becomes greater than the atrial pressure. Ventricular pressure gets it gets greater than the atrial pressure. So AV valves will close. AV valves will close. And this produces a sound that is first heart sound. But now you tell me which valve closes first, mitral or tricuspid? Mitral valve closes before the tricuspid. That's why you may listen a split S1. You may listen a split S1. S1 split may be heard. Are we clear, guys? Now I go towards the rapid ejection phase. So what is the beauty of this phase? Isovolemic contraction. Sir, the ventricular motion is maximum. Sir, ventricular motion is maximum, sir. Sir, the pressure is increasing approximately 10.6 kilopascals. That is 80 mmHg. Okay. So you are increasing the pressure more than the aorta. You are increasing the pressure more than the aorta. Are we clear? So 80 mmHg aorta, 10 mmHg pulmonary artery. Okay. And in the isovolumetric contraction, which valve should you open? You should open after this which valve? You are right now closing it, but I am telling you which valve should open after it. You should be having opening of aortic and pulmonic valve. Aortic, because you have to, now you are generating the pressure meant, what is the purpose? Is to send the blood towards the whole body. Okay, so will I say in the isovolemic contraction, the end diastolic volume is same and ventricular motion is maximum. So ventricular motion is maximum. Ventricular motion is max, but EDV is same and diastolic volume is same because you are isovolemic. You haven't done anything. You haven't ejected. Now I take you to the rapid ejection. So beautiful phase. This is the hero. Rapid ejection. Ventricular pressure is becoming so much more than the aortic pressure. Ventricular pressure is becoming so much more than the pulmonary artery pressure that during the isovolumetric contraction, semilunar valves will open. They will open. And the blood will rush out with a tremendous high velocity. The tremendous high velocity they will come out. Are we clear? So tremendous high velocity they will come out. Okay, because you have generated the pressure. So tremendous high velocity you have done the isovolumetric. You are now in the rapid ejection. So you should open the aortic and pulmonic valve. Is it clear? And should like the same way like the rapid filling, after that we have diastatic phase, should I also have a slow ejection phase here so that the ventricular pressure is decreasing? Now the ventricular pressure will decrease because it has ejected everything. So it is now going into decreased ventricular pressure and ejection velocity is reducing. So you should remember after this there will be coming off which phase after this rapid. What is special about rapid ejection? Valve status. What is the valve status? Open. Which valve open? Semilunar valve. That is aortic and pulmonic valve. Aortic and pulmonic valve. What is the velocity? High. Velocity high. Ejection rapid. Ejection rapid. Why this happened? Ventricular pressure became more than the aortic and pulmonic artery pressure. Aortic and pulmonic artery pressure. Is it clear, guys? Going to the last phase, that is the slow ejection phase. There is nothing more to speak about this phase. Okay, so slow ejection phase is the phase when you are having a reduced ejection velocity. Reduced ejection velocity because not therefore, because ventricular pressure is decreasing. Ventricular pressure is decreasing. Are we clear with the phases of systole? Are we clear with the phases of systole? Are we clear with the phases of ventricular diastole? Okay. So I think I don't need to repeat it. I think we have done it, understood it very nicely. We can have now the look at the diagrams. We can have an understanding of the diagrams in the last phase of this lecture. So isovolumetric ventricular contraction is the contraction. Okay. So isovolumetric ventricular contraction we can see what is happening is atria is, so you have isovolumetric ventricular contraction. That means the isovolumetric contraction, I should be having what? I'm increasing the pressure against the closed valve. I'm increasing the pressure against the closed valve, isn't it? This is systole. So this is closed, and I'm increasing the pressure. Okay, I'm increasing the pressure. Okay, so AV valve closed, aortic pulmonic valve closed. Now I'm going into ventricular ejection. It will eject the blood directly like this, isn't it? Blood is going like this. So what is here happening? This is closed. AV valve closed, pulmonic valve open. Atrioventricular valve closed, aortic pulmonic valve open. Here both closed because you are increasing isovolumetric. Going downwards, diastole, guys. Cardiology is so tasty, guys. Diastole, isovolumetric relaxation. That means I am relaxing. That means AV valve should close. Very nice. That means aortic and pulmonic valve should close. Very nice. We are understanding the, isn't it? No, isovolumetric ventricular relaxation. How can AV valve open, guy? We are doing diastole, ventricular isovolumetric relaxation. Okay, I am taking a middle phase. Okay, I took a middle phase so that you remember phase wise now. You remember a specific phase. What is happening especially in this? Okay, same. Ventricular filling will happen when? When will happen the ventricular? Still it is closed in that phase, isn't it? Diastolic phase first starts with that closure only. Now it will open. Now it will open. Okay. And you have to keep the aortic and pulmonic valve in closed form in the diastole so that you can do the filling work. Okay. And this is your atrial contraction. So which phase should it be? Which phase according to us it should be in the diagram? Atrial contraction. L, yeah, or P, F, or passive active filling, sorry, or active filling. I'll be able to understand, guys. So I hope you have enjoyed this topic. We will be taking a next video on the graphical presentation of this cardiac cycle. Okay, I hope you enjoyed it. Please subscribe to this channel, and I'll be uploading more videos like this. So thank you very much. Take care. Bye bye.